Let me start recording this. I'm still a little bit unfamiliar with how this works. Let's see. If I want to open OneNote, that's probably my best drawing tool. And draw. So let's make sure you can see my drawing. Good.
Yep.
And
Looks good.
Eraser. Ooh. Oh, didn't switch. Medium eraser. Okay. Whoops. Okay. Do you have any, I realize you haven't gone back to class yet, right? So do you know what you're going to be working on?
I'm not too sure actually, since before we left we had a test, so I think we may be getting new material soon.
Okay. We're getting close to the end of the year, so I would imagine that what are your and my goals should be, I suppose, to prepare you for your semester final, right?
Yeah.
And that's only going to cover the material from this semester. It won't go back to last semester?
Yeah, just this one.
Okay. So, all right, let me see what kind of material I've got here. Can I collapse it? Yeah, shrink controls. Good. Okay. Let's see. We don't want to go back to last semester. So we probably don't want to do this one that I had pulled up. This is linear area and volume relationships. I believe that's what you ended up last semester on. Is that correct? Or is this stuff you did?
Yeah.
You didn't do this year then?
No, this is last semester.
Okay. Close that one out. And let me see if I can find something more appropriate. In fact, why don't you, this is my list of files that I've built over many years. Just recently I started naming them so I could get back to them good. This is from February 16. That may be from you, although I have quite a few geometry students, but that could be something we would want to look at. We got circles and sectors also. You remember these kind of problems?
Oh, yeah.
Was this semester?
This was this semester, I think. Yeah, it was.
Let's see, how do I blow this up? Where's my zoom button? See more. Huh. Interesting. How do I zoom in on this? Do you know? Show all.
How about the bottom left, there's a little magnifying glass.
That's a search.
Oh.
Apologize for this. I knew there were going to be a little bit of hiccups in getting used to this new operating system.
What if you use the scrolling on the mouse?
Do what?
The little, are you using a laptop or a computer?
A computer.
So the little wheel on the mouse, could you scroll in on that and it'll bring it up bigger, maybe?
Oh, no, but it changes right to left. Wow. That's cool. I wasn't sure we wanted to do that, but this for sure is on your test, right? Or this is this semester, these
Yeah.
questions you're looking at right now? Okay.
Yep.
I'll figure out how to expand it eventually. You can see this, can't you?
Yeah.
Okay. Let me see if I can figure out how to get my drawing. How do you resize windows? Do you know?
Um,
In other words, how do I get
I can tell
full
you.
screen drawing? How do I? That's what I don't like about Windows 10, is that I want to be able to get two windows up there at the same time and be able to do problems. So what if I just move? Let's see, we're probably going to spend the whole time on this. Let me get rid of everything else here. Calendar I don't need right now. I don't need that. I figured out how to do this once before. We're putting these side by side, but I don't know how to blow these things up. It really shouldn't be called windows anymore. It doesn't look to me like I have any capability of I got one there and one here. Now I'm catching on. Now we're talking. Now if I, no, okay, we may have to live with this until I learn it. Let's take this is your paper, isn't it?
I think so, yeah.
Still worth reviewing. Okay, number one. What's the area of the shaded region going to be? How are we going to do it? Explain conceptually.
Well, we use the apothegm, not the apothegm, the radius given to us to find the area of the circle, and then multiply that by 220 over 360.
So area equals pi r squared, and
yeah,
the area of the sector is equal to pi r squared times what?
220 over 360.
That's going to give you the area of the white.
Oh, we're looking for the black then?
The shaded region. In all these problems, it's the shaded region.
Okay, and then that's just 140 over 360.
Okay. And I think that's all we need to do here, is to set it up. I'm not that caring as to whether we come up with answers here. That's just arithmetic. Let's look at number two. A little bit more complicated. How are we going to find the shaded region of that?
Well, what's a chord?
This is the chord right here. A chord is a straight line that connects 2 points on the circumference. In other words, if I have a circle and I connect 2 points like that, that's a chord. It doesn't look like a pen when I put it over there. Draw with mouse or touch. So conceptually, shaded region problems are almost always what? This first one was not a subtraction problem. Well, in a way it kind of was, right? In other words, to figure out the arc measurement, we had to subtract 360 minus 220, and then we applied it. Well, most shaded region problems, number three is the same. Number three, we're going to find the area of the big circle, subtract out the area of the small circle. Number two is a little harder. Number two is one of the harder ones here. So how am I going to do it conceptually?
I'm not too sure.
Well, let's look at it as a subtraction problem. So if we're going to turn it into a subtraction problem, what am I going to do? What am I going to start with before I start subtracting stuff away?
Well, we find the area first.
Of what?
Of the circle.
Okay.
And then we can...
So it's the area of the circle minus what?
The shaded area, the segment of the shaded area.
No. The shaded area is what we're trying to solve for.
Okay.
So if we start with the area of the circle, now we have to start subtracting stuff from it. Well, what's the first thing? I don't know how to figure out the formula for the whole white area. But we do know how to figure out the formula for this sector, which is everything but the triangle. And then we can figure out the area of the triangle. So conceptually, what am I going to do? I'm going to have the area of the circle minus what?
Minus all the white area. Is that 252 degrees?
Yeah.
Describe everything that's white or just the segment?
No, just the sector. In other words, the sector is always from the center. So this area here is the sector, not including the triangle.
Okay.
That's not what a sector would be. We don't have the math or the ability to figure out that whole area in one step. However, we do know how to figure out the area of the sector. So we're going to subtract the area of the sector off. And then what else? We have to subtract out all the white area. So at the moment...
Yeah, so we can have to get rid of the middle triangle.
Okay, so the area of the triangle. This is the way I would like to see you attack all problems, is with this first step. In other words, figuring out your game plan is very, very important. If you immediately try to solve this without that first step, it's extremely difficult. So now let's start filling stuff. What's the area of the circle?
That would be pi 10 squared.
So 100 pi.
Yeah.
What's the area of the sector?
Then,
what's the area of the sector?
That'd be, what's that number on the top, 252?
Yes.
Okay, so that'd be the same thing times 360 over 252.
Almost. 252 over 360.
Okay.
Always make sure that that number is less than 1. In other words, we're taking the area of any sector has to be smaller than the area of the whole circle. So if I multiply it by 3, if I multiplied it by 360 over 252, I'm going to end up with a sector that's bigger than the area of the circle, which we can't have. Okay? And finally, the last step, what's the area of the triangle? And let's just draw that triangle. This is also a very good idea. When you have figures mixed together all in one figure, in other words, we have this shaded region, we have a triangle, we have a sector, it's helpful sometimes to pull the triangle out and let's see if we can dimension it so we can figure out what its area is.
Okay.
Just the chord length. 16.
16.
Okay. What do we need for the area of that triangle? What's the formula for the area of a triangle?
1/2 the base times the height. So we have to divide, we have to cut that triangle in half so we can find the height of it.
Okay. What's the base. We know the base. 16.
That's 16, yeah.
So what is the height? What is this h right there? We can't solve
the height would be...
Yeah, since that's a right angle there, let's deal with this triangle right there. Okay? But to deal with that triangle, we have to come up with this length. In other words, this measurement from there to there, right?
It's 6.
Half.
The height is 6.
Okay, this is 8. Let's do this one step at a time.
Yeah.
And then what kind of triangle is this?
Okay. It's a right triangle.
It's a right
so
triangle.
So you use the Pythagorean theorem.
Okay, that's fine. Also, it's a 3, 4, 5 triangle.
Okay.
And if you learn to recognize those, it makes the math a whole lot easier because you don't have to apply the Pythagorean theorem. Although you're getting pretty good at it. We've worked on that. And that is a skill you want to maintain. Being able to solve all right triangles given two sides is very important. That you be able to do it and that you be able to do it quickly. Only because you have to do it so much. There are so many geometry problems that involve you solving right triangles. So, now what's the area? The height is 6. So let's erase. Let's try the stroke eraser. Bigger. Okay. So that's our answer.
Okay.
100 pi minus whatever this number is, minus whatever that number is. And when you take away all the white area, the only thing you're left with is the shaded region.
Okay.
Okay. Number 3. Conceptually, always start there.
Okay. Well, first you find the area of the entire circle, and then you find the area of the smaller white area, and then you subtract the smaller from the bigger.
Notice the subscripts. I don't know if your teacher does that or not. I find it very helpful with these kind of geometry problems. In other words, this means the area of the big circle, this means the area of the small circle. That's going to equal the area of the shaded region. Okay?
Okay.
What's the area of the big circle?
Pi 9 squared.
It's not 9. It's 16.
Oh, 7 plus 9. Okay, so
right. They
16.
They wouldn't draw it like that if it was 9. They would draw it like this. They would have this area here as 7, and then they would have this radius, and maybe that would say 9. Okay? They would never draw it on top of each other. Whenever they put two dimensions like that together, this 9 cannot possibly be that whole radius. It's just this distance here. Okay. So, let's fill in the numbers. It's the area of the big circle. I mean, let's get it set up with numbers, and then we can go on to the next problem.
Area of the big circle is pi 16 squared. And then the small circle is pi 7 squared.
Okay. don't think we need to do this one. The only way this differs from number 1 is that they give us a diameter instead of a radius.
Okay.
So what's the radius of 4?
The radius, that's just 4.
Okay, cool.
Centimeters.
Okay. Let's do 5. 5 is another relatively difficult one. I mean, 5 is a lot like 2. So, what's our beginning place?
Finding the area of the circle.
Our beginning place is coming up with the complete first equation. In other words, the area of the shaded region is going to be equal to what?
What do you mean?
Well, what did we do on number 2? We had the area of the circle minus the area of the sector minus the area of the triangle. That's what I want to see.
Okay.
So what is it here?
The area of the circle minus the area of the triangle area.
Sector first. In other words, you don't have to take out the sector first, but that's the easy one to get. In other words, sector areas are pretty easy. We're going to have to do some work to figure the area of that triangle. But that's the way I'd like to see you start every one of these problems. Now, area of the circle?
That is, I don't see any radius or anything like that.
I don't either. So, got to figure out the radius. Now, notice the radius is the hypotenuse of one of these triangles. Okay? And the question is, can we solve one of those triangles? The fact that that's 120 degrees says what about this central angle?
The sector?
No.
That is
central angle, this triangle that is going to end up looking like this.
Yeah.
The only thing we know about it is that that's a right angle, and that's 4.
Okay.
Okay. But we know something else about it. We know what that angle is. What is that angle? A central angle is always the same as the arc that it cuts out. So if that's 120 degrees, that's 120 degrees.
Yeah.
So if that whole thing is 120 degrees, what is this angle 1 right there?
$60 degrees.
Okay, good. So now we have this triangle. That's a 60. Got to be a 30 because it's a right triangle. We know this is 4. So I got to figure out how to get more space here. Don't have quite enough space to draw.
So we know the hypotenuse is 8, right?
Yes. How'd you know that?
Because the right angle rules or something like that.
Okay. The reason you...
Because the hypotenuse is 2 times the size of the short leg, and then the long leg is...
The reason you know it is because you're very familiar with this special triangle. That side is 1, this side is square root of 3, and this side is 2. And so you correctly surmised that the similarity ratio was 4:1, which makes the hypotenuse not so much double this, although that's correct. That technically the way I'd like to see you solve these kind of 30-60 triangles is find the similarity ratio with your unit one. In other words, as long as you always remember the dimensions of the unit one, then you can always solve these 30-60 right triangles even with just one dimension. Okay? So we have a radius. So now let's start substituting. What's the area of the circle?
Okay, so the rate, it's pi 8 squared.
So 64 pi. It's the area of the sector. Always always figure out what the measurement of that arc is, because that's going to be a critical number.
120 degrees?
No, that's the measurement of this arc. What's the whole thing? The whole thing is 360 degrees. So what is the measurement?
Okay, yeah.
There to there.
120 over 360.
No, that would be the part of this sector. In other words, if I treated this whole area as a sector, it would be the area of the circle times 120 over 360. But we're not talking about this area yet. We're talking about this area here. So it's got to be the area of the circle times what ratio? There's the area of the circle. What part of the circle is this? That's what you're always trying to figure out. Is that half the circle? Is that?
It's a third of the circle.
It's what?
A third. 1/3 of it.
This part here?
Well, I can't see what you're pointing to. It doesn't show me.
Oh, I didn't realize that. I apologize. This part right here. Does that look like one?
Oh, okay. That's 2/3.
That's the sector, right? That's the part of the sector that we're trying to get rid of, right? In other words, the sector we're talking about, don't get confused as to which sector, because there's always lots of sectors. In other words, even problem 1 had 2 different sectors. So to figure out the area of any given sector, you always need what part of the circle is that. And that is always the measurement of the arc measurement divided by 360.
Okay.
So it's 240 divided by 360. That's the arc length of this sector is 240.
Okay.
Okay. And the very last thing is the area of the triangle. Well, we kind of have solved this triangle, have we not? Not quite. We need the area of the base.
So it's...
What is the area, what is the length from there to there?
The 4 times the square root of 3.
Very good. Using those similar triangles, and the ratio is 4:1. So what's the length of the whole base?
8 times square root of 3.
Correct. So I'll let you go here in a second, but let's finish this problem. So that's 8 root 3. What's the area of that triangle?
1/2 the base times the height.
So 1/2 8 root 3 times 4. There you go. That's how you get it.
Okay.
But can you kind of see why if you always start with this, then it's just a question of filling in each one. We know how to find the area of the circle, the sector, and the triangle. If you don't start with this top line, these problems are going to be extremely difficult.
Okay.
Okay?
Yeah.
All right, Mark. I will see you tomorrow at our regular time. I guess I did need my calendar up, huh? I hate Windows 10. I got to figure it out. I got to go through their tutorial. But I'll talk to you tomorrow. Okay?
See you, David.
All right. Bye-bye.